Hello, hereby in this video we are going to describe our project color detector. It detects the color based on the recorded RGB values of the given input color. Here RGB stand for the red, green and blue values of the input color. We have used some small circuit consisting of one LDR and resistor of 10 kilo ohms. This is the resistor of 10 kilo ohms, and one Arduino. This is a Arduino, and we have two RGB LEDs. This is the input RGB LED to flash the RGB colors on the input, and the other is used to display the output showing the same output color. This is made to show the efficiency of the color detector. To make this circuit to work more efficiently, we have made this in a closed box so that the dark conditions are produced. Because the brightness varies from place to place, this setup is being made. This working is starting whenever we run the code, that is like it is already burned in the Arduino. That is like it is already burned in the Arduino. Here the code will be burned here the code will be burned, and then the in Arduino will be starting running. RGB color starts flashing here simultaneously on the input object, and the red color present in the input object is reflected and absorbed by the LDR, that is light dependent resistor, and same happens with the green and blue when flashed on the input object. Now LDR absorb the reflected percent of colors and change its resistance respectively. As the resistance changes, voltage also changes, and these values are recorded as the analog signal. Recorded values are received by the Arduino. Here the values are mapped from 0 to 255 as RGB values in any color varies from 0 to 255. These values are displayed in the serial monitor. These recorded RGB values are resent as the PMW signal to the output RGB LED. This is the output RGB LED, and this receives the corresponding values, and the respected color is displayed on the serial monitor. Now let us take some colors and check the output. Now let us take it as black for the first. This is the black object which we are going to give as an input object. Just placing this above the LDR, we are going to run the code. By running the code, this is the running code, and this is the serial monitor we have over here. This is the serial monitor. Here the RGB values are shown 000, displaying the black, and here when you see it is a black object, and the output LED isn't being clone as it is the black color. Hereby we end the black color testing, and now we go for the white color testing. This is the white color, same as black. We are going to put the white sub object above the LDR, and we are going to test in the serial monitor. While testing in the serial monitor, hereby we will be getting the RGB values maximum, as the white color has the maximum values, and you see the output LED will be glowing white. See, this is just a plastic dome placed over the output LED so that the white light is displayed. And hereby we are going to use another intermediate object color. This is the intermediate color, blue color. This is the blue color object we are going to use for the testing. Again, we are going to run the code on the serial monitor. Hereby you see the serial monitor and RGB values for the blue. Yeah, it's been 198, 174, and you can see the output LED displaying the same color exactly of the given object color. In the you see we can get an online RGB calculator calculating these values. When you check out the values, it is 198 and 174. Just putting those values here, we'll be getting, yeah, the same color is being displayed in the online RGB calculator. So hereby we can conclude that the efficiency of a color detector is accurate, and its accuracy is 99.9%. So hereby this is our project color detector, and it's done. Thank you.